Mercury is crumpling. Right now, as you listen to this, the smallest planet in our solar system is collapsing in on itself. Its iron heart is cooling, and as it cools, the entire planet contracts, and the surface cracks. Mile-high cliffs erupt across the landscape. The ground splits open along fault lines hundreds of miles long. We dismissed Mercury for centuries. The runt. The boring one. A scorched rock too close to the sun to matter. But when we finally sent a spacecraft to look closely, what we found was not a dead world. It was a dying one. And the way it is dying could one day, according to simulations published in Nature, rearrange the entire inner solar system, including us. This is the true story of Mercury. The planet that was murdered, the corpse that refused to stay still, and the ticking clock buried in its orbit. We ignored it. The smallest planet, the closest to the sun, the hardest to see. Mercury hides in the glare of our star, appearing only briefly at dawn or dusk before vanishing again. Even the ancient Greeks were not sure it was a single object. They gave it two names, Apollo for the morning appearance and Hermes for the evening, before realizing it was one body darting back and forth across the sun. For most of human history, we knew almost nothing about it. We could not even agree on how fast it spins. Until 1965, astronomers believed Mercury was tidally locked, one face permanently turned toward the sun, roasting in eternal fire, and the other frozen in permanent darkness. A world split in half. Fire and ice. It was simple. It was elegant. It was completely wrong. Radar observations from the Arecibo Observatory revealed something far stranger. Mercury rotates 3 times for every 2 orbits around the Sun, a 3-to-2 spin-orbit resonance found nowhere else among the major planets. This means a single day on Mercury, measured from sunrise to sunrise, lasts 176 Earth days. That is longer than its year, which is only 88 Earth days. A day that outlasts a year. And at certain longitudes, during certain points in Mercury's eccentric orbit, something happens that defies what your brain expects from a sunrise. The sun rises above the horizon. Then it slows. Then it stops. Then it reverses direction, sinks back below the horizon, and then rises again. A double sunrise. On some parts of Mercury, you would see the sun set, hover, and then set. Mercury does not even get the sun right. But the scars tell a different story than simple strangeness. When NASA's Mariner 10 flew past Mercury in 1974, it photographed less than half the surface. What it saw looked like the moon. Craters everywhere, grey and beaten. Scientists shrugged. Another dead rock. But Mariner 10 also saw something that did not fit. Long, curving cliffs running for hundreds of kilometers across the surface, cutting through craters, slicing through plains. They called them lobate scarps. These were not erosion features. They were not ancient riverbeds. They were thrust faults, places where one slab of crust had been shoved up and over another by enormous compressive force. The planet was being squeezed from the inside. And then there was the Caloris Basin, one of the largest impact craters in the entire solar system. 1,550 kilometers across, roughly a third of the planet's diameter. Ringed by mountains 2 kilometers high. Roughly 3.9 billion years ago, an asteroid perhaps 100 kilometers wide slammed into Mercury with a force that defies comprehension. To understand the scale, picture this. The crater is wider than the distance from London to Madrid. The mountains around its rim would tower over anything in the Alps. The shockwaves from the impact did not just ripple outward across the surface. They traveled through the interior of the planet and around the curvature of the crust, converging at the exact antipodal point, the spot on the opposite side of Mercury, 180 degrees away. And when those shockwaves met, they did not just rattle the ground. They shattered it. The landscape at the antipodal point is a chaotic jumble of hills, fractured ridges, and disrupted terrain that looks like the surface was shaken apart from below. Scientists who first saw this region on Mariner 10's photographs gave it a name that stuck. They called it the weird terrain. That is the official geological term, not a nickname. The weird terrain. Mercury was hit so hard it broke on the other side. But the real shock came later, when we finally saw the whole planet. In 2011, NASA's Messenger spacecraft became the first to orbit Mercury. Over 4 years, it took more than 270,000 images and mapped the entire surface. And what it found changed everything we thought we knew. First, the scarps. They were everywhere, not just where Mariner 10 had photographed. Thousands of them, crisscrossing the planet in every direction. Some stretched over 1,000 kilometers. Enterprise Rupes, the largest, rises more than 3 kilometers above the surrounding terrain and runs for roughly 1,000 kilometers across the surface. That is a cliff taller than anything on Earth, on a planet smaller than our moon. Imagine standing at the base and looking up. 3 kilometers of sheer rock face rising into a black sky. No weather to soften it. No erosion to round the edges. Just a raw wall of stone thrust upward by the planet's own agony. Scientists calculated the total contraction by surveying more than 5,900 surface features. Mercury's diameter has shrunk by up to 14 kilometers since it formed. The planet is crumpling like a tin can being slowly crushed by an invisible hand. But the most disturbing discovery was not the size of the cliffs. It was their age. Some of the scarps looked young. Disturbingly young. Small, sharp-edged fault scarps cutting cleanly across tiny craters, meaning they formed after those craters, meaning recently in geological terms, perhaps in the last few tens of millions of years. Mercury is not a fossil record of ancient violence. It is still shrinking, still cracking, still producing mercury quakes right now on a world we call dead. And then Messenger found the ice. This is the part that makes planetary scientists lose sleep. Mercury is the closest planet to the Sun. Its daytime surface reaches 430 degrees Celsius, 800 degrees Fahrenheit. Hot enough to melt lead. Hot enough to melt zinc. The temperature swing between day and night is over 1100 degrees Fahrenheit, the most extreme of any planet. And yet, hiding in craters at the planet's north and south poles, in places where sunlight has never reached, Messenger's radar found water ice. Not a trace. Not a hint. Billions of tons of it. Here is how that is possible. Mercury's axis is tilted by less than 1 degree, almost perfectly upright. This means the Sun always hangs near the horizon at the poles. The rims of deep craters there cast permanent shadows on their floors. Permanent does not mean long-lasting. It means eternal. No photon of sunlight has touched the bottom of some of these craters in billions of years. The temperature in those eternal shadows stays below minus 170 degrees Celsius. Colder than the surface of the Moon. Colder than most places on Mars. Some of the coldest natural vaults in the inner solar system exist on the planet closest to the Sun. The ice arrived via comet impacts over billions of years. Some of it may have outgassed from the interior. However it got there, it stayed, preserved in darkness, covered by a thin layer of dark organic material that insulates it from the faint heat that bleeds in from surrounding terrain. NASA calculated there is enough ice in Mercury's polar craters to bury Washington, D.C. under a layer 2 miles thick. On Mercury. On the surface of a world that melts metal at noon. But Mercury is not just strange. It is dangerous. Look at the inside. Mercury's iron core occupies roughly 85% of the planet's radius. For comparison, Earth's core reaches about 55%. Mercury is almost all core. A giant iron ball wrapped in a thin shell of rock barely a few hundred kilometers thick. No other planet has proportions like this. Something is deeply wrong with Mercury's body. The leading theory is violence. Early in the solar system, when planets were still forming from a disk of dust and gas, proto-Mercury was likely a normal-sized rocky world with a thick silicate mantle, proportioned like Venus or Earth. And then something found it. A collision, possibly a glancing hit-and-run impact with a body several times Mercury's current mass, ripped the mantle away. The lighter rock was stripped and scattered into space. The dense iron core survived. A 2025 study using smooth particle hydrodynamic simulations found that a grazing collision between two similarly sized rocky embryos reproduces Mercury's composition better than the older single giant impact model. What we see today is not the planet Mercury was supposed to be. It is the skinned remains of a larger, murdered world. A planetary corpse with its skeleton exposed. And the scars of that murder are not just in the proportions. They are in the chemistry. But here is the twist. When Messenger analyzed Mercury's surface chemistry, it found something that should not be there. Sulfur, potassium, sodium, volatile elements that evaporate at high temperatures. If Mercury had been through a mantle-stripping collision violent enough to expose its core, those volatiles should have been vaporized and lost to space. But they are there, coating the surface, leaking from the interior. Messenger even discovered thousands of shallow, bright depressions called hollows, places where volatile materials are actively sublimating into space right now. Mercury is not just shrinking, it is evaporating. The planet is losing itself in two directions at once, collapsing inward as the core cools and dissolving outward as volatile compounds escape into the vacuum. And the atoms blasted off the surface by the solar wind do not just vanish. They stream behind Mercury in a long, glowing tail of sodium that stretches millions of miles into space. You can photograph it from Earth with the right telescope. Mercury has a comet tail. The smallest planet in the solar system looks like a comet. It is bleeding light. In 1% of those simulations, Mercury does not just die quietly. It takes us with it. In 2009, French astronomer Jacques Laskar and his colleague Michael Gastineau at the Paris Observatory published a paper in the journal Nature that shook planetary science. They used the JADE supercomputer to run 2,501 simulations of the solar system's future over the next 5 billion years, using the most accurate orbital data available and accounting for the effects of general relativity. The question was simple: is the solar system stable? The answer was not. In 99% of the simulations, the solar system remained more or less intact. Mercury wobbled but survived. The planets stayed in their lanes. But in 1%, roughly 25 simulations, Mercury's orbit went wrong. Its eccentricity, the elongation of its elliptical path around the Sun, increased slowly over billions of years until Mercury's orbit crossed that of Venus. At that point, chaos. Mercury either crashed into Venus, spiraled into the Sun, or was flung out of the solar system entirely. But in one particular simulation, something far worse happened. Mercury's destabilization did not stay contained. It transferred angular momentum to Mars.
Mars's eccentricity spiked. Venus shifted.
And 3.34 billion years from now, in that specific computed future, the entire inner solar system came apart. Mercury, Venus, Earth, and Mars all destabilized. Out of 201 sub-simulations run from that destabilization point, 29 ended with Mars colliding with Earth. 18 ended with Venus colliding with Earth. And 1 ended with Mercury itself hitting our planet. 1% sounds small. But the solar system has been running this experiment for 4.5 billion years already. And it has at least that long to go. The margin is not comfortable. It is the definition of chaos. A change in Mercury's orbit of less than half a millimeter over 140 million years, amplified by Jupiter's gravity, doubling in effect every 10 million years until the inner solar system unravels. Now imagine standing on Mercury's surface during the long day. The Sun hangs enormous in the black sky, 2.5 times larger than it appears from Earth, blazing with a ferocity that would kill you in seconds without a suit. There is no atmosphere, no haze, no clouds, no blue, no color in the sky at all. just pure black above and scorched grey rock below, split by cliffs that drop a mile straight down. The ground beneath you is cracking so slowly you cannot feel it, but the faults are there, fresh, still growing. The silence is total and permanent. No wind. No sound carries. Behind you, the temperature is 430 degrees. Walk a few hundred kilometers toward the pole, descend into one of those shadowed craters, and you would cross into minus 170 degrees. The temperature difference between standing in sunlight and standing in shadow on Mercury is greater than the temperature difference between the surface of the Sun and the inside of a blast furnace. And trailing behind the planet as it races around the Sun at 170,000 kilometers per hour, faster than any other planet, a comet tail of sodium atoms glows faintly against the void. Mercury is bleeding into space. In 2015, Messenger ran out of fuel. NASA had a choice. Let it drift and eventually crash uncontrolled, or aim it. They aimed it. On April 30th, Messenger slammed into Mercury at 8,750 miles per hour, creating a new crater roughly 16 meters wide. After 4 years, 270,000 images, and a complete rewrite of everything we thought we knew, the spacecraft became part of the planet it had studied. A tiny scar on a world made of scars. And right now, another spacecraft is on its way. BepiColombo, a joint mission between the European Space Agency and the Japanese Space Agency JAXA, launched in 2018. It has spent 7 years falling sunward, using gravity assists from Earth, Venus, and Mercury itself to slow down enough to enter orbit. It has already completed multiple flybys, photographing the polar craters and the scarps from angles Messenger never achieved. When it arrives in orbit in 2026, it will deploy 2 separate orbiters. One will map the surface and probe the interior with unprecedented detail. The other will study the magnetic field, the only global magnetic field on any rocky planet besides Earth, which is inexplicably offset toward Mercury's North Pole and only 1% as strong as ours. BepiColombo will tell us whether the planet is still tectonically active, whether the ice deposits run deeper than we think, whether the hollows are accelerating, and whether the cooling core is driving the strange magnetic asymmetry. It is the most ambitious Mercury mission ever attempted. And it is arriving at the right time, because Mercury is not waiting for us. Mercury does not need to be big to matter. It is the solar system's dark horse, the overlooked runt that carries the most unstable orbit of any major planet. A world that was violently stripped of its skin billions of years ago and still has not healed. A world that hides ancient ice in the shadow of its own craters on a surface hot enough to melt metal at noon. A world that bleeds sodium into a comet tail millions of miles long as it races around the Sun faster than anything else in our neighborhood. It is shrinking. It is evaporating. It is seismically active. And buried in its chaotic orbit, amplified by Jupiter's gravity over billions of years, is a 1% chance of destroying everything. We called it dead. But the cliffs are still growing. The hollows are still deepening. The tail is still streaming. Mercury is the smallest planet in the solar system. It is not the quietest. If you found this fascinating, subscribe and stay curious. We have barely scratched the surface of what our solar system is hiding in plain sight.